In this video, we will continue in the Options menu. This time, we will navigate through the calculation options that can be customized. The calculation options specify important parameters regarding the calculation methods used for your model. The first tab simply displays some information about the currently active model. The next tab allows the designer to open up the convergence criteria. This can be useful for large, complex networks which are struggling to converge. However, adjusting these settings is not recommended unless there is a justified reason for doing so. When adjusted, it is also recommended to have the settings return to defaults. It is also important to return to default settings using this button when finished to maintain the highest level of accuracy. The global settings allow us to specify the value of some constants and assumptions. Assume zero flow assists model convergence, especially in very complex systems. With this, pipe sections experiencing flow equal to or lower than this setting during the iteration process are considered in the calculation as zero. These are removed as a component in the complex iteration process of the software. The inclusions allow us to automatically include a correction factor for centrifugal pumps used for high or low viscosity fluids relative to water. It also can consider losses due to expansions and reductions on either side of a control valve. We could also set up an iteration process to obtain a more accurate friction factor across all possible flow regimes. The convergence aids are very helpful in systems where open pipes or resistances are present in the model. It sets up the calculation to prevent the occurrence of backflow originating from open pipes or resistances in the model. The heat transfer section allows you to select the pipe heat loss outside coefficient model to be used on component heat loss calculations. The Gas tab can specify the reference conditions for gas system volumes either in normal or standard conditions. We could also set up the calculations to include or disregard the Joule-Thomson effect in various heat transfer models applied on components. Also included on this tab are options for gas lines experiencing condensation due to heat loss. Users can consider their models to have a system with or without a steam vapor trap arrangement. The two-phase tab is used to specify which flow correlation will be applied in the calculation. As default, it applies the Whaley criteria. Selecting this option allows the software to select the appropriate method from the three correlations available when using this approach. The non-Newtonian and slurry tab allows users to select pressure loss correlations to be used and values to be applied in slurry and non-Newtonian and flow calculations. Different correlations applied by the software for heterogeneous settling slurries can be also found in this tab. It also includes the configurable selection of deposition velocity correlations. This tab is also used to specify the constants applied to some of these correlations. Here, users can also configure model assumptions, such as considering inclined piping when elevation differences and pipeline criteria are detected. Having this assumption automatically adjusts pressure losses and deposition velocity calculations based on inclination. It can also set up solid particles as all spherical in settling and deposition velocity estimations. Pulp and paper stock allows users to select pressure loss correlations. When the default TAPI correlation is used, this tab also enables the selection of the TAPI pulp size to be applied. If Mahler method is selected otherwise, the tab can be used to define the pulp property constants used for this correlation. When the applied changes to all open networks is checked, all the settings configured in the calculation option are applied to all modeling files opened. Clicking the default box stores the setup preferences when reopening FluidFlow files. Also, clicking Reset to Defaults returns the entire options to its original configuration. Now that you've seen how to modify calculation options, you can customize various criteria and references for the solver. This includes changing the correlation used to calculate the pressure drop and deciding which considerations to include or exclude during the calculation. In the following video, we'll explore the environment options in detail.